Welcome to Integrated Math 3, Notes 6-3. These ones should be pretty quick. All right, let's get started. We're on page 85 in the book. Page 85. All right. Okay, so it says today we're going to compare properties of two functions, each represented in a different way. So for example, we may have two different cubic functions, and one is a graphical display and the other one's in an equation. And then we're going to solve polynomial inequalities by graphing. So you can represent polynomials algebraically, that would be like as a function, graphically, or in a table, or even by verbal description. We're going to today and on the exam be comparing a function in equation or algebraically to a graph. Okay, so it says each of the following represents a polynomial. They're both fourth degrees, right? This is a fourth degree. This is has 1, 2, 3 inflection points, or it changes direction 1, 2, 3, 4 times. So it is a fourth degree polynomial. And it says, work with your group, use any method you'd like to answer the following questions and justify each answer. As you justify your answers, speak clearly and use precise mathematical language to describe your reasoning and your conclusions. Remember to use complete sentences, including transition words such as and, or, since, for example, therefore, because, etc., etc. All right, it says which polynomial has a larger maximum value? A larger maximum value. All right. So we're going to look at this polynomial, right? The maximum value, they're not talking about a relative. They mean the absolute maximum value. The maximum value of this one, well, it's upward facing. It's going to go on forever. And so the maximum value here would be positive infinity. And it's on either direction, right? To the left, it's approaching infinity, and to the right, it's approaching infinity. This polynomial, right? This polynomial is also a fourth degree polynomial. If I were to graph this polynomial, it would be a downward facing polynomial. Downward facing because a is less than 0. So it would look something like this. So even if these points, these relative maxes are really, really high, they will not be at infinity. Therefore, this polynomial, the graphical one, will have a higher maximum value. So the graphed polynomial will have a larger max value because it is upward facing and therefore the end behavior approaches infinity. Okay. Oh, let me zoom out a little bit so you can see that a little better. There we go. Okay. All right, and so then it says which polynomial has more real roots? Okay, well, this polynomial, this is a double root here at -5, and then it has a root at 0, and then it has a root here at +6. So this polynomial, it does have 4 zeros, but one of them is a double 0. So our solutions on this polynomial would be x plus 5, x plus 5, x and x minus 6. This is our factored form. I shouldn't say our roots. These are our factors, right? Our roots are x equals -5, x equals -5, x equals 0, and x equals +6. So here are our roots for this one. Okay, the other one, to know, I'm going to have to solve this. I'm going to solve this by factoring. And so I have f of x equals -2x to the 4th plus 10x squared plus 72. always look for your GCF. There is a GCF, right? I'm going to set this equal to 0, and I'm going to factor out the -2. That would give me x to the 4th minus 5x squared minus 36. All right, since I'm solving, I can go ahead and divide everything by -2. And that gives me 0 equals x to the 4th minus 5x squared minus 36. When I solve this polynomial by factoring, I'm looking for something that multiplies to -36 and adds to -5. Those two numbers are -9 and +4. And so I'll factor this by grouping x to the 4th minus 9x squared plus 4x squared minus 36. I'll take out the GCF of each side. The GCF of this side is x squared, and that gives me x squared minus 9. Bring down my plus sign. The GCF here is 4, and that gives me x squared plus, minus 9 again. I have to come down here. Right. I've got, pull out my GCF of x squared minus 9, and that gives me x squared plus 4. And then remember, this is equal to 0. Now I'll set each factor equal to 0. That gives me x squared minus 9 equals 0, and x squared plus 4 equals 0. Add 9 to both sides, I get x squared equals 9. Square root both sides, I get x equals plus or minus 3. Subtract 4 from each side, I get x squared equals -4. Square root both sides, I get x equals plus or minus 2i. All right, so this polynomial has a double root at, not a double root, it has a root at 3 and -3. So this polynomial would cross the the x-axis at 3 and -3. It would be downward facing, so it would have in behavior going down, down. The y-intercept would have been way up at 72, so we'll just fake that at 72. And this graph would not cross through the x-axis again. Oh, in fact, this point should have been the max, or the y-intercept, but regardless, because it was an even function. But regardless, these two imaginary solutions, right, they're on the complex plane. It's not going to cross the x-axis at 2. That's 2i. So this one will only have 2 real roots, whereas this one has 3 distinct real roots. And so the graphed equation, the graphed function has more real roots, since the algebraic function has 2 imaginary roots. Okay, I'm going to fix this graph for you guys. It should have bent right here. It should have come up, bent, and come back down, something like this. So this is incorrect. It should have done something like that. It was an even function. So it should have symmetry on the y-axis. All right, which of the above polynomial has the larger y-intercept? Justify your answer. I know the y-intercept of this polynomial is 72. The y-intercept of this polynomial is, the y-intercept of this polynomial is 72. The y-intercept of this polynomial is 0. And so the algebraic representation the y-intercept was 72 versus the graphed, it was 0. So therefore the algebraic one has a higher y-intercept. And it says, for which of the polynomials above is f of 1,000 smaller? Justify your answer. So you could substitute in the number 1,000 into this graph, into this function, and you're going to get that regardless, right, f of -1,000, or sorry, an f of 1,000, you're going to get a, if you look at the graph here, if this is 1,000 over here, you're going to get a positive value no matter what. And if you plug in 1,000 over here, you're going to get a negative value. So regardless, you can see that the algebraic has a smaller y value when x is 1,000. So the algebraic has a smaller y value when x equals 1,000. And that is because it is downward facing at 1,000, and it's approaching negative infinity, actually. It approaches negative infinity on when x is approaching 1,000. All right, moving along. I'm going to rip this page out so that I can flip it over for you guys. Okay, it says to solve a polynomial inequality by graphing, we're going to use the fact that the polynomial can only change signs at its zeros, right? It only changes signs at its zeros. And so this is kind of an application of Descartes' rule from yesterday. So Descartes' rule, remember, it said the number of the number of roots, right? The positive and negative roots, it happens at every sign change. So it's an application of that. So we're going to write the polynomial inequality with one side equal to 0. We're going to graph the inequality and determine the zeros, and then we're going to find the intervals where the conditions of the inequality are met. All right, so let's apply that. So here's our polynomial, and it says the first thing is we need to get it, one side equal to 0. So to do that, I'm going to add 30 to both sides. So my polynomial is x to the 4th minus 13x squared plus 36 is less than 0. All right, step 2, it says to graph the inequality and determine the zeros. Well, to do that, you can use a graphing calculator if it does not factor, but if it factors, then you can figure out where those solutions are, right? So that's what we're going to do. We're going to figure out where our solutions are. So this does factor. We're looking for something that multiplies to 36 but adds to negative 13, which would be negative 9 and negative 4. And so when I factor this by grouping, I will have x to the 4th minus 9x squared minus 4x squared plus 36 equals 0, or sorry, less than 0. Split it, take out the GCF of each side. The GCF here is x squared. That gives me x squared minus 9. Bring down my negative. The GCF here is 4. That gives me x squared minus 9 again. And now I'll take out my GCF, which is x squared minus 9, and group my two terms, x squared minus 4. And remember, this is less than 0. And then I will set each factor less than 0. X squared minus 9 is less than 0. X squared minus 4 is less than 0. And then this factors further, right? Or you could square root both sides, but this factors further. You get x squared minus 3x plus 3x minus 9 is less than 0. This one also factors further. You have x squared minus 2x plus 2x minus 4 is less than 0. Factoring this one, take out the GCF, you get x and then x minus 3. And here you get plus 3 and then x minus 3, all this less than 0. And so we'll take out the GCF again. We get x minus 3, x plus 3 is less than 0. And here, right, I'm going to have to come down here. I'll have x squared, take out the GCF. So I'll have an x and then x minus 2, bring down my positive 2, and factor out the 2, x minus 2. Group these together, x minus 2, x plus 2, and remember this is less than 0. And so I have my 4 roots are at x is less than 3, right? I'm going to set each of these less than 0. X is less than negative 3. And then I have X is less than 2, and X is less than negative 2. And so my 4 zeros are at 3, negative 3, 2, and negative 2. So when I sketch this guy, my graph will look something like this. It'll have a solution at 2 and at 3. It'll have a solution at negative 2 and at 3. The y-intercept will be at 36. That's way up here at 36. The end behavior is positive to the left and to the right. So this graph will do something like this. It'll come down, come back up, hit the y-axis, come down, come back up, and that will be my graph. Now, remember, the only thing that's different is that instead of having it equal to 0, it says solve where the polynomial is less than 0, right? Less than 0. So it says find the intervals where the conditions of the inequality are met. So they're asking you on your graph, where is this graph less than 0? So less than 0 means negative, right? Less than 0 on the y-axis. All of these values down here. So my answer would be it is less than 0 between negative 3 and negative 2. So between negative 3 and negative 2 for x. It's also less than 0 between positive 2 and positive 3. There we go. All right, so the answer to this inequality, they're asking the answer to this question was, this inequality, where is the graph less than 0? The graph is less than 0 on the interval from negative 3 to negative 2, and on the interval from positive 2 to positive 3. All right, they have some check your understandings. It says to solve the polynomial by graphing. They have already factored it for us, so we are not going to have to factor it. So that's a step that we can avoid. So the first, because remember it said to get one side equal to 0, determine the zeros, and then find the intervals where the inequality's conditions are met. So our inequality is x plus 9, x plus 2, and x minus 4 greater than 0. Okay, this time we're looking for values where the graph is positive. So we sketch this graph. I see that my leading coefficient, right, if I were to multiply these out, I would have an x to the third power, and it would be a positive x to the third. You can check that if you'd like. Multiply them out, use a generic rectangle, then do it again with a generic rectangle. But I can see that my end behavior is positive, or sorry, that my leading coefficient is positive, which means that, and it's a cubic, my graph will be decreasing to the left and increasing to the right. I can also see where my y-intercept is. It's 2 times 9 is 18. 18 times negative 4. 4 times 18 is 72. It's way down here at negative 72. And then my solutions are at x equals negative 9, x equals negative 2, and at x equals 4. So it will be crossing at 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 9. It will be crossing again at negative 2 and again at positive 4. So to the left, it's coming up, going back down, it's going to hit the y-axis and come back up again. And there is my sketch of this polynomial. Now, this time it's asking where it's greater than 0. Greater than 0 means positive, so above the x-axis. So the intervals for which that happens is between negative 9 and negative 2. So between negative 9 and negative 2. And again, after positive 4. And again, after positive 4. And it never decreases again. And these are the intervals on which this graph is greater than 0. All right, the next one, right, we'll do one more. This is number 5. We'll also do the check your understanding number 6. So check your understanding number 6 says to solve this polynomial by graphing. the polynomial they've given us is x cubed minus 2x is less than 0. All right, so we have to solve it. They have not solved it for us. The first thing we do is look for a GCF. There is a GCF, it's x, and then that's x squared minus 2 less than 0. And I'm going to set each factor equal to 0. And this one is already solved. This one, I'll square root both sides. I get x equals plus and minus the square root of 2. Now the square root of 2, we have to estimate that on the graph when we graph it. The square root of 2 is 1.141 about, so x is about 1.41. And we're going to sketch this graph. I see that it is a cubic function with a positive leading coefficient. That means that it'll be decreasing to the left and increasing to the right. The y-intercept will be the constant term, which there isn't one, so it's 0. The y-intercept is at 0. Oh, look, that was one of my zeros. And then I know also that there's a 0 at about negative and positive 1.41, which is about right there. So this graph will do something like this. And so now it's asking you for the intervals upon which it's less than 0. Less than 0 means where the graph is below the x-axis. And so the intervals that happens for is from x is less than, right, so going to the left, less than the square root of negative 2. Or you could say x is less than negative 1.41 approximately. And then it also happens between 0 and 1.41. So you could say 0 is less than x is less than the square root of 2. Or if you're estimating, you could say 0 is less than x is less than 1.41. And those would be the intervals on which your graph is less than 0. All right, guys, that was notes 6-3. Please make sure that you do the homework for both lessons. I will be posting the review, the last part of the review, shortly. Thank you.